Excellent. All the invited speakers will have 15 minutes to talk, and all the internal, all the people from Brunel will have 10 minutes to give their presentations. In terms of questions, because we have so many speakers and very short talks, we thought it would be best if you all type your questions in the chat box, and then if the talk finishes early, the speaker can answer the question as part of the session. But if the talk does not end early, then basically the speakers can answer in text after their talk, or perhaps some of the questions we can also take along for the panel discussion. Okay, lastly, I'm reasonably on schedule, I see. Here's the agenda for today. So obviously you're listening to my welcome and overview of the program. There will be a first session, which I will chair, starting with talk, a sort of general overview talk from Diana, followed by a talk by Christoph Schweimer about location graph extraction, which is very important for simulation construction. William Lowe will share his thoughts about doing forecasting in Ethiopia, notably about the Tigray conflict. So there will be very much from a humanitarian and humanitarian research perspective. And then Ali Reza will talk about how to couple FLI with weather data and across different skills so that you can do things in more detail. Yanni will cover a multi-objective optimization, so repurposing the simulation to, for example, find the ideal spot to open up a new camp. She has started work on that very recently. And after that, we'll have a quick break. During the second half, Diana will chair the session, and then Nikela and Petros will talk about the parallel computing part, about running larger simulations of FLI more quickly using supercomputers. Michael will talk about the use of FLI in an operational setting and also about exploring uncertainties. Samuel will talk about forecasting conflicts, which is very important because if you forecast migration, you also need to have an idea about how conflict develops, but you don't want to perfectly forecast the conflict. So he will have a discussion about that. Then Nathan from Georgetown University will give a talk which is not directly about FLI, but very much related, and he also would like to sort of tie in with the FLI community, and he will talk about spatial temporal analysis of internal displacement in Iraq. And last but certainly not least, James Unwin from the University of Illinois Chicago will talk about Markov chain models of refugee migration data. After that second session, we'll have a panel discussion. The main title is The Future of FLI, Where Would You Go? And I will be chairing that discussion, and then at the very end, we'll have some concluding remarks. Basically from our side, this is basically the team that has been working on FLI. So there's myself and Diana, of course, Hamid and Ali Reza, who've done a huge amount of technical work on FLI and the tools around it. Yanni has done multi-objective optimization. Samuel has been working on conflict evolution, and also David Bell, Simon Taylor, and Anastasia Anagnostou, who have been involved with all the overarching projects. Okay, I will stop sharing my screen now. So let me see. And then I guess we can start with the first session. Diana, are you ready to share your screen?
Yes, Derek.
Okay, very good.
So let me share my screen. Can you see my screen?
Yes, feel free to start straight away.
Sure. So I'm just gonna make this slide. Yeah. So I would like to welcome everyone. As Derek mentioned, the invited speakers, the participants, we're very happy to see you here. And to start with this workshop, I think the best option was for me to provide some overview about the FLI algorithm, what it is, and what we do within our research group. So this talk will focus on modeling forced migration using FLI algorithm. As Derek already introduced our team, everyone is involved in this work. So to start with, our main motivation was when different types of conflict erupted in different countries, especially in Africa, and that we were focusing on, we knew that people flee from their own home countries. But the question that we had is, where do they go? And can we actually predict their arrivals in order to help organizations effectively allocate humanitarian resources in order to support people forcibly displaced? So another question that motivated us in order to do our research was, how do humanitarian decisions affect them? In particular, when there is a border closures between countries and they're not receiving or they're not allowing anyone to enter the neighboring countries, or the camp placements. For instance, if we have a situation where we have people moved from one camp to another, relocated. And also another motivation was to inform decision making and possibly public awareness by doing our research. After understanding these main motivations, what was our objective, and what it still is the main one is that refugee movements matter, and it's important to be able to predict where they go for three main reasons. First is in order to save their lives and help governments and NGOs to correctly allocate humanitarian resources, as I mentioned. And then the second one is to complete incomplete data. So what we faced in our work is that most of the time there's incomplete data that's available for researchers. And the third reason is to investigate the consequences of the nation closing its border for refugees. So by understanding and having our motivation as well as our objective, we proposed a simulation development approach focusing on forced migration movements. So what we did was, first, we decided to which country we're focusing on, and we chose also a period that we wanted to simulate and predict the movements for. After identifying that country with a period of conflict, what we decided is that we need to have data sources that we can actually publicly extract data from. And those are, in our instances, our UNHCR data repository, which provides us the total number of refugees fleeing from the country, as well as the camp names and the camp numbers. The second was ACLED conflict location event data project, which provide us conflict data. And third one was this OpenStreetMap. After extracting this data from these databases, what we've done is that from ACLED, we took conflict zones, from UN, we took the camp names and where they're located. We connected these two different locations with OpenStreetMaps. After constructing this model for this country that we were working on, what we did was we actually refined our model with different types of information that we extracted from reports. For example, it can be border closure, any redirections, or camp capacities that camp had. After defining this model, redefining it, we executed using the FleetCode. I'll provide more details what is FleetCode and how it works. And we run different types of simulations. It can be ensemble, or it can be one instance, or it can also have the sensitivities tested that we have within our rule set. We obtained our results and we validated against the UNHCR data. So this simulation development approach was proposed, and then we applied it to different countries. In order to provide the insight about the FLEE rule set, so what we have is that there is one time step, which means we simulate per each day. And each agent who was the refugees, refugee in this instance, they decide whether they stay put in the conflict zone or that they actually move to a neighboring location. So on the right-hand side, for example, you can see an overview of South Sudan network map that we constructed after identifying the conflict zones and camps. And then if they decide to move, where they're gonna actually go. So that was also within the rule set that we identified. As I mentioned, each agent represents one displaced person, and again, humans are smart, but agents are not, but we were able to make simple autonomous decisions by providing the rule set within the FLEE. Key assumptions within the FLEE rule set is that we have the total number of refugees and the conflict progression, as you saw in the network map, for instance, and we predict how they actually arrive to neighboring countries. We placed people in conflict zones, and then every day, as we simulated our models, people were moving towards the camps. And then agents have chance whether they move or they chance to pick which direction they would like to go within the network map. And then camps have capacities, they're equal to the maximum number of population. We restricted it due to the fact that we cannot have more than people in the camps, and then they have the maximum speed and the walking speed as well. After having the FleetCode is an agent-based code, it's written in Python, it's available on GitHub, and it's open source. If anyone would like to try to access it, you can see the link there. And then we obtain our simulation results, and simulation results, as you can see, it's out.csv files, simple .csv file, and we have number of days in the first column and different types of camps. For instance, in here we have camp D, E, and F, and we have our simulation data compared against the UNHCR data that we got, and then it also calculates the error between this simulation and data. And in the all, we also have the total error, how much is our prediction is actually accurate compared to the actual data. And we actually use that, and we try to visualize our results by using different types of graphs. For instance, here we have the actual simulation data compared to the UNHCR data for the Mubera camp. And then we have the error term validation. So when we get different types of validations for different types of instances, when you change the rule set, you can actually see that the changes within our error. And we can also visualize it using the general map construction. The main simulations we have so far is for Mali 2012, Nigeria 2016. We have also Central African Republic, South Sudan, Burundi, as you can see the dates there. And then the Syria is one of our latest constructions. And of course, with the Save the Children, we've been working on Ethiopia conflict that's happening at the moment. So for Mali, Central African Republic, South Sudan, and Burundi, we achieved prediction of 75% accuracy when we compared our results to the validation data. And also we've collaborated with UNHCR in relation to South Sudan and IOM in our also different predictions. Last thing that I want to mention is that our research is not only restricted on predicting the number of people arriving to neighboring countries. We've so far done different types of simulations. So first instance is ensemble simulations, which means that you have different instances of different types of scenarios that you have for the people moving. And we were able to do that. We actually did also sensitivity analysis for our different types of rule set parameters. We forecasted, for instance, for the Ethiopia. We also coupled that you can hear today in the talks from Alireza in relation to coupling macro micro models and weather, for instance. We've also done some work on the food security coupling. And latest things that we have in our team is the conflict generation model and multi-objective optimization in relation to the camp locations. So any questions, please let me know. Thank you.
Wow, excellent. On the dot, 20 past one. Very good. If you have any questions, please put them in the chat, and Diana will be able to respond to you during the in the chat during the next talk. Our next speaker is Christoph Schweimer from the No Center. Christoph, are you ready to share your screen?
Yes, just a second.
Okay.
This one, I hope you can see my screen right now.
Yes, yeah, sound quality is good. So feel free to go ahead.
Okay, perfect. Thank you very much. And also good afternoon from my side. And thank you very much for the introduction. Today, I'm going to talk about graph pruning and how it can be applied to construct location graphs. There we go. The method was developed within the Hidalgo project together with our partners at the University of Stuttgart and the Brunel University in London. At first, I'd like to talk about graph pruning itself and then how it can be applied to construct location graphs, go over some of the results that we obtained, and give a short summary in the end. For graph pruning, we need some very basic concepts from graph theory. A graph, which is a tuple consisting of a set of nodes that we are going to denote as L and a set of edges that we are going to denote as E. And for the edges, we have corresponding weights that for location graphs are going to be distances. This is why we are going to denote it with a D. We also need to know what a path is. And a path is basically a sequence of nodes together with a sequence of edges that connect the nodes. And therefore, to compute the path distance, we are just summing over the individual edge distances. Now, graph pruning corresponds to the idea of graph simplification. And here the idea how to simplify a graph is that we want to remove some of the edges from the graph. And the further idea is that we'd like to find the smallest graph where the shortest path distance in the original graph is equal to the shortest path distance of the pruned graph between all pairs of between all pairs of nodes. There are several approaches on how to apply graph pruning. One is a global strategy, where for an edge, we try to find the shortest path between the two nodes that are connected by the edge. And the pruning condition is that if the distance of the edge is bigger than the distance of the path, then we can remove the edge from the graph. For instance, here on the left-hand side, we have an edge between the two nodes B and F, and one of the paths that connect the two nodes B and F is the path BAEF. And here we see the distance between the two nodes B and F is equal to 5, and the sum distance is equal to 4. Therefore, in this case, we can remove the edge from B to F from this graph. A second approach is a more local approach, or also triangle approach, where here the idea is that we are looking at all paths between two nodes that have exactly one intermediary node. So to go back to this example here, we have again the paths, the edge between the two nodes B and F, and the only triangular path between the two nodes is the path BCF. If we sum up the individual edge distances, we have that the path BCF has a total path distance of 6, which is bigger than the distance between the two nodes B and F of the direct edge, and therefore we cannot remove this edge from the graph. So we have now seen that the global approach is, or it can be shown that the global approach is giving optimal solutions, but it is computationally not very efficient. Whereas the triangle approach is computationally more efficient, but we have seen it does not give optimal solutions. So how can we now combine the two approaches and reap the benefits of each of the two approaches? For that, we are making two assumptions. The first one is that we are operating on a complete graph, such that every node is connected to every other node. And the second assumption is that the path distances satisfy a monotonicity property. And in our case, this property is that for a path with several intermediary nodes, that there exists one node on this path such that the triangular distance is smaller or equal than the total path distance. And with those two assumptions, it can be shown that triangle strategies are optimal. For the construction of location graphs, we have also further enhanced this approach by relaxing the pruning condition, which we can see here on the right-hand side. We incorporate a parameter beta, which is being multiplied by the path distances. And with that, when we choose beta to be smaller than 1, we are adding more flexibility, but I will come to this flexibility at a later stage in the presentation. So how can we now combine this approach and the ideas? This is where we come to the algorithms around pruning for complete undirected graphs. The algorithm starts with a complete graph, and we are choosing a pruning parameter. At first, we are making a copy of the fully connected graph, and the idea behind that is that we are always checking our pruning condition on the original graph, but we are applying the pruning on the copy of the fully connected graph. What we are doing then is we are iterating over all ordered triplets of locations. So you can imagine you are basically looking at a triangle. And in each triangle, we are trying to see, can we remove the longest side of the triangle? And what we are doing is, this is approximately here, we are saying that if the longest side of the triangle is bigger than the sum distance of the two smaller sides of the triangle, multiplied with the pruning parameter beta, then we can remove the longest side of this triangle from the copy of the fully connected graph. And after applying this idea or to all ordered triplets, the copy of the fully connected graph is the resulting graph. And next I want to show how this idea with this algorithm can be applied to construct location graphs and where it is necessary. As we've heard before in the talk by Diana, the migration use case in the Hidalgo project deals with the simulation of forced migration. And the necessary input here is a graph structure where the nodes correspond to physical locations, the edges correspond to direct routes between the locations, and the edge weights correspond to route distances. And this is basically the location graph. These location graphs have been created manually, which is a time-consuming and error-prone process, such that we developed a two-step procedure to construct these location graphs automatically. As input, we need a list of physical locations with their GPS coordinates. And in the first step, we are connecting each location to each other location via the fastest driving route. This gives then a complete graph that satisfies the monotonicity property that was presented in a couple of slides earlier. In the second step, we are pruning the graph by removing indirect routes, and this is being done by the route pruning algorithm. And the output is then a location graph of direct driving routes. And here we can see why this pruning parameter of beta is necessary, because when you go from one location, I hope I can get this in the screen somehow, when you go from one location, from A to B, and and you compute the route from A to B, and there's a third intermediate location somewhere near this route, going from A to the intermediary location, and from the intermediary location to the location B is always going to be a little bit longer than the direct route. And if you multiply the sum distance of the two shorter routes with the pruning parameter beta, this pruning condition is relaxed, and we can remove the longest, we can remove this route from location A to B because it goes very, very close by this intermediary location. Next, I want to go over some results and show the functionality really quickly on a short example. Here we have 15 locations in the federal state of Styria in Austria with their GPS coordinates. In the first step, as mentioned before, we are computing the complete graph where now every location is connected to every other location. In the next step, we are applying our route pruning algorithm. And we have done this with a value of beta being equals to 0.9. The resulting graph is looking like this, where we can now see that we have a major reduction in driving routes between the locations. We have also applied the algorithm with a value of beta being equals to 0.95. And what we would expect here is that now more locations are connected to each other. And this is indeed the case when applying the algorithm with beta being equals to 0.95. We have in this instance 4 more connections left. You might now wonder how good does the algorithm actually function? And this visualization here gives an overlap of the results from the route pruning algorithm as the black dashed line. And in yellow or orange, it shows the result that we got from the manual creation of the ground truth. And what we can see here is that there is a nice overlap between the two. And to give you a little bit of background, it took around 2 hours to create the location graph manually. And with the algorithm, it took about 2 seconds. So we also see that there's a major reduction in location graph construction time. We have also quantified our results, where we can see here in the last column the F1 score, and we see that for 2 different values of beta, we have obtained an F1 score of 0.95 in this region. We have also applied the algorithm in 3 other regions, most notably in the 2 conflict scenarios in the Central African Republic and South Sudan. And here in the results, again, in the last column, we see that for each of the 4 regions, we were able to obtain an F1 score exceeding 0.7. To give a short summary, we have developed a computationally efficient route pruning algorithm that can create location graphs within just a couple of seconds in regions where we have only a small amount of locations. And even for whole continents, we were able to create location graphs, which then took a little bit longer, obviously. We have also incorporated a pruning parameter for flexibility for our results. And also what I want to mention is that the results that were presented have to be interpreted a little bit carefully, because in some instances, the creation of the ground truth was not straightforward. But overall, we achieved good results in 4 regions of different size and road infrastructure. And for further information, I would like to refer you to our article, A Route Pruning Algorithm for an Automated Geographic Location Graph Construction, that you can find in Scientific Reports. And with that, I want to say thank you very much for your attention, and I will gladly answer any questions.
Okay, thank you very much for your talk, Christoph. We actually have 2 minutes left. So if people have any questions, feel free to raise your hand or unmute and ask the question.
So this is Michael Puma. I just had a quick question. So this is really nice capability. So I was just trying to think in terms of application. If you're adjusting parameters like travel speed and things like that, I mean, so that could adjust the weights and sort of you would have automatic or relatively rapid readjust or pruning of the graph. Is that the idea? You know, as situations develop, if the weights on your distance graphs start changing, you can do this in a more automated fashion. Is that fair enough?
The idea is to create these location graphs really quickly within just a couple of seconds or a couple of minutes. As we are using data from the internet, from the open source routing machine, we very much depend on the results that we get from there. So if they are quick in the background to update their software and their platform, then this will also be seen in the algorithm. I hope this answers your question.
Yeah, I'll just elaborate on it very briefly. So yeah, essentially this is all about the initial construction of the location graph and connecting the locations and figuring out which routes interconnect which locations, because you don't want all locations interconnected with all routes, because many of the roads are overlapping. And that's why you need this pruning algorithm to take out all the routes that actually aren't direct routes between locations, but actually, according to OSRM, go through other places. So that's very much where this algorithm is geared towards. So it's more or less a starting point for the kind of dynamic location graph optimizations that you're talking about, Michael. Not sure
okay, great.
Helpful.
Yeah, I was thinking like on the fly, if you so you do your initial pruning, you have a graph, and then you know, say there's changes to your system that you have to update the routes. So I mean, I guess it's a step towards that direction, I would imagine.
Yeah, exactly. By automating this thing, then later on, if you want to make changes, that could also become more easy, because you start capturing this by parsing online data and automating the whole procedure.
Yeah, very nice. Thanks.
Okay, great. Thanks a lot for your excellent talk, Christoph. And then we'll move on to the next speaker, which is William Lowe from Save the Children. William, are you able to share your screen?
Yep. Okay.
Right.
Visible?
Yeah. Yes, sound, image is good. I see a screen share being loaded.
Okay.
Yes, and now I can also see the slide. So
okay.
Yeah, thanks a lot for taking part in the workshop, and feel free to get started straight away.
Fantastic, thanks. Thanks, Derek, and thanks, Diana, for organizing as well. So hi, everybody. So yeah, I'm Will. I work at Save the Children in our migration and displacement team. So today, this isn't going to be a technical presentation so much as to kind of show the evolution of what Save has been doing in this space and why we've settled on ABM through our partnership with Brunel. I think so people can get a sense of how organizations like Save the Children are thinking, perhaps. I hope it's sufficiently interesting. And as Derek says, I absolutely encourage anyone to reach out if kind of any part of this does resonate with you. Okay, so just a little bit of context setting. So in terms of the kind of global displacement, we're 4 times where we were 15 years ago, and this is only trending up, and we're going to see probably a really dramatic increase in this as climate change really starts to contribute more and more to migration and displacement. Not just the overall scale, but also the duration of displacements is going up. I think the average duration is what, 10 years, and we're regularly seeing them go. I think more than 25%, maybe, is more than 20 years now. So really, the trends are not super great. Now, for Save the Children, we have this core focus on children. Displacement has a absolute disproportionate impact on them, on their health, their education, as well as their kind of ongoing exposure to harmful situations and risks. And going back to duration, as that creeps up, a lot of children who become displaced or are born into displacement will quite possibly spend their entire childhoods displaced, which I think we can all agree is a pretty grim reality. So Save the Children and agencies like it obviously respond to displacement, but we have kind of big challenges around data gaps and data quality that limits how effective and efficient those displacements are, particularly in the early stages of a displacement when data is very light. So, without knowing how many people are going to be displaced, where they'll be displaced to, what proportion of them are children or women and girls or kind of other, groups with specific vulnerabilities and needs. This is about having getting the right resources in the right place. And without this kind of data, we can't do that. Now, that data isn't available through traditional means. So we, like other organizations, have been increasingly, starting to turn towards predictive analytics as a way to fill some of these data gaps and this kind of crucial data. So yeah, if we can reliably generate this missing data, our kind of interventions are going to get they're going to get more relevant. They're going to get much more efficient. We'll be able to do more with the money we have, but also being able to fill some of these gaps also puts us in a stronger position to advocate for the funding we need with governments and kind of other donor organizations. So we're kind of moving into our third phase of the project that I'm looking after, which is called predictive displacement and focuses on this problem. So the first phase predates me, and this was based on a pre-existing relationship between Save and Boston Consulting Group, and they did a bit of kind of early prototyping, just a very simple approach leaning on random forest to build basically decision trees that categorized mass displacements into one of 3 categories for scale and one of 3 categories for duration. So fine as a proof of concept, but not so useful for kind of operational or strategic purposes. The bins are too big. Duration itself is a flawed concept. These displacements never meaningfully return to kind of a 0 state. What we're talking about really is kind of scale over time. But so kind of flawed and kind of, but showed a kind of successful kind of proof of concept and kind of need, and gave us the impetus to kind of keep going with the project. So then we moved into our second phase. And so here we focused on building new partnerships, and we had this initial emphasis on kind of classic machine learning approaches, looking at kind of annual predictions. We were coming from the starting position of the BCG work. So started with this vision of a kind of a single global model that could be applied in kind of any case. Now, it quickly became evident, a single global model like that is just not really possible right now. But rather than jump straight to individual countries, we moved to we wanted kind of clusters of countries, which kind of displacement characteristics can be grouped. Reasoning being that it gives us more data points within cluster groups, and also when a displacement occurs in a country where there's no history of displacement, we're not kind of starting from absolute square one. So yeah, we did a lot of, I mean, and this work's ongoing, a lot of experimentation, but we hit some kind of key constraints. So this approach on the kind of scale we're talking about draws on big open data sets, some of the big prestige data sets, like UNHCR data, for instance. But of course, that data is pretty temporally constrained, one data point a year for a given refugee population. And then also, I mean, I don't need to tell you guys, these are data hungry approaches, and we just don't have that much data to offer it. And the data we do have in the sector, is messy. Even the leading data sets, the methodologies have changed, definitions have altered, different levels of rigor and coverage over time. There's gaps in data. So this, makes these kind of classic approaches pretty challenging. Now we're still working in that space, and it does have utility. Some of you probably seen the DRC's Foresight model. They brought out a nice report this year. There isn't much detail on the model itself, but it shows that there is a kind of good practical kind of use to these approaches for kind of big, more zoomed out kind of multi-year predictions. And there are really good applications there for kind of big picture planning and advocacy. Our machine kind of learning workstream is in a pretty similar place to that work, but the kind of constraints we kind of found in that space is what led us to agent-based approaches and to Brunel. Yeah, moving into this kind of third phase, kind of overlapping our kind of second phase. But so I kind of thinking through our kind of work with Brunel is that, these agent-based approaches, they offer a chance to rely less on that slightly problematic historical data that we have these issues with, and instead draw on resources that we do have, which is, local insights and experience into patterns of behavior and decision making, and kind of being able to reduce different sources of data, sometimes kind of messy data, into behavioral data that we can use to inform the model. It also lends itself really well to more zoomed in, kind of geographically centric kind of models that can be kind of more easily folded into our operational work and planning at the kind of country level. So as I think was technically the focus of this was about modeling Tigray, which is what we've been doing with Brunel. So yeah, initially our focus was actually on Burundi, but we pivoted with the kind of current and still ongoing Tigray kind of crisis in northern Ethiopia. So you can see here the geographical network that underpins the model, with the kind of travel network between points. So these are settlements, conflict locations. Green are the essentially the camps. So those are kind of onward processing points. And so the model basically introduces conflict events according to our scenarios, and then plots the movement, as as we talked about in the previous talks, of these populations across the travel network, eventually building predictions for their arrival in the camps in Sudan on the left. So the scenarios vary by intensity, number of conflict events, and by geography. So increased conflict in West Tigray, East Tigray, or all across it. The model is based on these key assumptions. These are adjusted based on insights from a variety of sources. We kind of hoover up whatever's available. So that's insights from local country teams, response mechanisms, reports and data coming out of the response, humanitarian situation monitoring. What we're really interested in is, and it can be hard to get insight into, is destination preferences in those populations. How do they decide where to go? So an interesting thing that came up recently, new insight, was that the camps in Sudan are quite ethnically stratified, which suggests that displaced populations on the move towards those camps probably have a preference for a camp that fits their own ethnic identity. So all this stuff can be useful inputs. Of course, then sometimes the methodology is working out how to fit that data in. So yeah, model output. So this is example plot based on 100 runs, which are, you know, you can see the gray lines. So this work with Tigray, this is still an evaluative kind of pilot. So watch this space. But yeah, the model has already shown some kind of interesting results. We found that geography of conflict seems to have more of an impact on destination trends than the intensity. And we're also able to build some kind of specific conflict arrangements that describe particular scenarios that we're interested in. So say conflict on a border, you know, we can observe upticks for arrivals in, you know, in camps based on that. I'm going to pick up speed a little bit. So yeah, what next? So yeah, next phase is around kind of refining, you know, what we've learned through this work into something that we can really share and promote. You know, initially you're talking about kind of building a kind of a bit of a front-end interface for this, thinking about replication. Demographics, obviously Save the Children, demographics really important to us, so that, you know, building that into the model. Yeah, so age, but also, yeah, also sex. And then for us, this is pretty operational. So it's working out how to integrate it into our program. So it's a sustainable process of being able to generate these models, which also means thinking about the skills that we need to cultivate within the organization, and kind of then to get that kind of necessary buy-in. And then yeah, finally, I think we want to share this work and its benefits more widely. We don't just intend for this to be a purely Save the Children utility. We actively want to share it and promote it and kind of partner around it in the sector. So I'll leave it there. Yeah, I hope that was interesting. Yeah, absolutely do get in touch if you're interested. I have an absolute open door. I'm always happy to talk this stuff through. And yeah, happy to field any questions with the time that's left. I don't have my data scientist with me, so I might defer any more technical questions, but yeah, always happy to talk.
Okay, great. Thanks a lot, Will. There is time for one quick question, I would say. Does anyone have a question they would like to well, does anyone have a question, basically? If not, I might ask a quick question, Will. In terms of priority, you mentioned that in the camps, there's this ethnic stratification, but then at the same time, there's also an age, well, of course, stratifying by age would also be very interesting. I guess most likely you would do one and then the other. Do you have any feeling about which of those two stratifications would be more important?
Yes, I probably shouldn't use, yeah, stratification I think was the wrong word. I think that was yeah, it's more about the camps. Some camps are particularly dominated by one ethnic group and another camp is dominated by another one. So I think that I guess we're more interested in that as a kind of a pull factor. So we just like, you know, that information is traveling across, you know, some kind of knowledge sharing network. So that's going to definitely be determining who goes where. You know, it's going to be a pull factor on the kind of displaced people moving towards them. I think, yeah, in terms of kind of, yeah, demographic and actual stratification, then I think, yeah, for us, yeah, we have an age, you know, we have this age focus, children, like being able to specifically cite children, that's our priority. But I think, yeah, absolutely, age and gender are equally important for us at this stage, because both directly inform the kind of work that we need to be doing in these, you know, in these camps from day one.
So we might have to pursue them in parallel then. Catherine left a question for you in the chat as well.
I can feel that.
I will move on to the next speaker. But thanks a lot for your excellent presentation, Will. And
thanks.
I guess we'll see you later on during the panel discussion.
Sure.
All right. Our next speaker is Alireza Yahani from Brunel. Alireza, are you able to share your screen?
Yes.
Okay. So Alireza will talk about essentially coupling Flea to other instances of Flea, but also to weather forecast and weather data. Feel free to go ahead, Alireza. Quality seems to be good.
Can you see my screen now?
Yes. Yeah.
So before I started, if during my presentation I lost my connection, I will reconnect it again in just a few seconds. So, because since the start of this workshop, it happened 2 times for me.
Okay, we'll see how it goes.
Sure. Yes. So supposing you're all get acquainted with the FLEE, I'm going directly to the coupling multi-scale migration simulation with weather data. We're focusing on the South Sudan conflict. We have decided to take the multi-scale approach for the South Sudan because in the northeastern part of South Sudan, we have different climates. So in that provinces of South Sudan, we have a lot of mountains, a lot of rivers. So literally the behavior of agents in those parts might be different. So this is why we divided the whole South Sudan model into two sub-models, macro and micro. And we developed this multi-scale simulation prototype based on FLEE for this conflict location. What we intended to do was to increase, of course, the level of accuracy in terms of force displacement forecasting. And we are sure that refugee decisions to move depends on the perceived level of safety and, of course, accessibility to their destinations and weather conditions, which might affect their decisions during their flight. So we have different coupling approaches. The two main coupling approaches we used as an interface between the macro and micro scale submodels are file input output and muscle tree. We tested both coupling approaches. These are the cyclic or two-way coupling approaches to interconnect these submodels. In the file input and output, our approach is simply exchange the data between these two submodels by using the local shared file systems. And for the muscle tree, we use the multi-scale coupling library and environment, aiming to simplify these scale-separated coupling simulation. And also, in order to couple with weather data, we used a cyclic approach to couple with the weather data sets provided by ECFWF. So, as I mentioned, we focused on the South Sudan, and let me explain a little bit about the South Sudan, which has a civil conflict flared up in December 2013. Almost 2 million people have forced to flee from to the neighboring countries. And we built this multi-scale model for the whole South Sudan. And as you see here, there are three provinces in the northeastern side of South Sudan, Upper Nile, Dongbala, and Jonglei. This is the location graph for the whole our South Sudan graph, and you see the inner rectangular shows the microscale model, and we need to interconnect the microscale and macroscale model. Our simulation period started from 1st June 2016 and ends at 31st July 2017. We have 58 conflict locations in macro model and 36 conflict locations in our micro model. We have 21 camps in neighboring countries, Ethiopia, Kenya, Sudan, and Uganda. And the main point here is that we have some coupled locations that can connect these submodels. So in the microscale model, we have additional models. I'm speaking in the technical parts. We have additional values for location and link types apart from the usual FLEE simulations. Both submodels have coupling links. As I mentioned, they are named coupled locations. And in addition to these coupled locations, we have some new feature in the multi-scale simulation, which means that we have added all the conflict locations in the micro model into the macro model without any links to other towns or other locations in the macro model. So because there isn't any links between these locations and they're just there, we named them as ghost locations. So in our procedure, the micro scale model insert agents into these locations according to the normal free agent insertion algorithm. And at each time step, the coupling interface, whether a file or input output or a muscle tree, can transfer all agents from each ghost location to the micro scale model. So about weather coupling, as you see in this workflow, the main important part of this coupling is to achieve the weather data and prepare these weather data in order to couple them in a cyclic manner with the micro scale model, not macro. So we only couple these data sets, which include precipitation level and river discharge level for these micro scale provinces. And I'm not speaking in how we couple them into our model, but I just want to mention that we use these data to find about whether they can affect the refugees' decision to move or stay in the conflict location, or if they decided to move, what these data can affect onto the flee's speed of our agents. So, for instance, if we have a lot of rains, a lot of precipitation in that period of time, in that specific time step, the road might be closed, or it can double the time of flee to the neighboring camps. So this is the main concept of using weather data sets and couple them into the microscale simulations. So
Anyways, you have 2 minutes, by the way.
Sure, it's going to be. So for more information about this weather coupling, you can refer to the below paper. And we, in that paper, we took 5 approaches and compared them together. You can see the preliminary results about this comparison between the taken approaches in about the total validation error, total execution time, and coupling overhead. And you can see the multi-scale models results in a higher validation error than single-scale model. However, in terms of the runtime, the multi-scale models outperforms the weather-coupled model. And this is very natural because we have more data to couple with. And this is the sample plots for the macro-scale and micro-scale model in the South Sudan conflict for all these 5 approaches. Thank you. If you have any questions.
All right. Thanks a lot, Alireza. Sorry, I was just typing a short explanatory comment in the chat. Okay, I think we'll move straight on to Yanni, but if you have any questions for Alireza, please do type them in the chat, and Alireza will then be happy to answer them there. Yanni, are you happy to share your screen?
Yes.
Okay, excellent. So Yanni Shui is actually a new research fellow in our group at Brunel, and she specializes in AI, but specifically in many objective optimization, where we have quite a strong research group here. And her talk is very much about finding the optimal place to place a camp if you were to place a new camp in a humanitarian situation. So she basically started exploring algorithms to find that out. Feel free to go ahead, Yanni.
Okay, thank you for your introduction, Derek. And today I would like to introduce our work on multi-objective optimization in forced migration scenarios. So let's modern societies modern societies face many challenges in the area of society, economy, and so on. And in this study, we're focusing on forced displacement, which is a complex global phenomenon, which is commonly triggered by many factors such as conflict, violence, and to save human lives, refugee management is one of the most important problems that governments and NGOs need to address. So camps are important infrastructures to provide protections and allocate available humanitarian resources to refugees. And as part of the Hidoko project, we would like to address the question faced by governments and NGOs, and that is where to construct refugee camps. This is an important problem because selecting optimal refugee camps locations could enhance the effectiveness of refugee resettlement. Camp location selection problem can be seen as a multi-objective optimization problem, which is a very challenging task, especially in the context of forced migration. The difficulties comes from three perspectives. One is that we have multiple objectives to be either minimized or maximized at the same time. In addition, we also need to satisfy several constraints. For example, related to camp capacity and so on. And finally, this problem have an uncertainty related to refugees movement. So to address this problem, I would like to explain our work. So first, let me show you the, let's look at the route network for camp location selection problem as shown in this figure, where we have three types of nodes, conflict zones, towns, and camps. And for each pair of nodes, well, we create a link represent its route between the two locations, and we each node have a pair has a pair of coordinates indicates its location. So this we will create a route network for conflict situation that we want to address. So this route network is constructed according to three steps. So first, we create a source country with conflict and town locations and all possible links among these locations. And second, we add a camp at a given coordinate in a destination country. And thirdly, we create a link between the camp to its nearest location in the source country. Here are two key assumptions for our model. The first one is we assume refugees move place to place for each time step according to predefined routes of the fleet. And then we also assume that refugees stop moving once they reach the camp. Here are three objectives for our model. So first, we would like to minimize individual travel distance. So the shorter distance is preferred. And second, we would like to maximize the demand covered by the camp. So basically, this is the the population that arrives to the camp at the end of the simulation. So the third objective is to minimize the average idle capacity over the whole simulation days. So based on this model, how can we solve this problem? So in our work, we attempt to use evolutionary algorithm, which is a population-based algorithm that mimics the natural selection. Because of its advantages over traditional optimization methods, evolutionary algorithms have been widely used for multi-objective optimization problems. In our work, we employed 3 popular multi-objective evolutionary algorithms as shown here. And in particular, the FLEE code will be integrated to use for the evaluating objectives in our optimization process. Here, I would like to show you a case study that we've done at this early stage. It's a South Sudan conflict, which have a simulation period of 604 days. And we also give the input variable bound, which basically means that the camp should be located in a square outside South Sudan. And the last thing I would like to mention about the setting is we run the simulations 6,000 times in order to obtain reasonable results from our MO perspective. And here I would like to share the results we've got so far. And as you, so basically there are 2 observations I would like to point out. So first, we can see that the solutions that indicated by the blue dot can be classified into 2 clusters. One is near the border between Sudan and South Sudan here, and another cluster of solutions are near the border between Congo and South Sudan. And another observation is that from this figure, we can see the locations in the camp locations in Sudan tend to obtain better objective values. On the first objective, which means shorter individual travel distance. And for those locations in Congo, they tend to achieve better values on the second and third objective that related to camp capacity. So this, so in summary, these results are very promising, and basically we can provide suggestions for the NGOs. So let's say we can suggest that NGOs could move the camps to the border between the South Sudan and Sudan. But apart from that, because of the Congo is not very stable, so we suggest NGOs could ignore this type of solutions. So these are just some early results of our algorithm. In the future, we would like to apply our approach to other forced migration scenarios in other countries. Okay, so that's all from my side. Thank you very much for your attention.
All right, thank you very much, Yanni. Yes, well, thank you very much for sharing this initial investigation using very advanced algorithms to basically detect the ideal camp location and then applying them to an actual simulation. So you end up running a large number of simulations. If there are any questions, please feel free to put them in the chat.
Hi, Derek. Can you still hear me? I actually have a very quick question.
Yes, of course. Go ahead. Yes, I can hear you.
Hi, here I'm also again. I thought this talk by Yanni was really, really interesting about where to place those camps. And I was thinking during the talk where else somebody could also apply the technique of not camp placement, but placement of other things. So we have encountered a problem during our work time where we are trying to optimize routes for garbage collections. And in one of the use cases, there was the idea, okay, we can place like a garbage truck at a certain location. So you can collect garbage around this and then take another round, collect garbage and so on. So my question behind this is is there like an algorithm or a paper that you read that helped you with the implementation, and what is the background for that?
Thank you very much for your question. At this early stage, we just use three popular evolutionary algorithms that has been widely used in our optimization field. And actually, I have I can share these papers with you if you would like.
Yeah, I think we can link the two of you up and then Yanni can share the papers. Would that be handy?
Yeah, totally. Thank you very much. That would be very helpful.
Okay.
I just want to add as well, like Christopher, we're planning with Yanni to actually contact you to use location graph extraction algorithm in order to connect camps with the conflict zones. So how we can actually modify and reiterate in the location extraction algorithm and make it more focused for her camp optimization examples. So we might be sending you emails in the coming weeks and having a couple of meetings maybe.
Okay, yeah, sounds great. I'm looking forward to it.
Sounds good.
Very good. Yeah, I see the remark from Will in the chat. I completely agree with that, William. I think the reason we started off with the camp placement is because we had an earlier paper as a starting point where some people looked into it before. So I had some collaborators in the States before where we looked into this particular problem. But the multi-objective optimization you could apply to any type of intervention. So it would indeed be very interesting to think about, okay, what other kind of interventions could we apply this approach to, and perhaps some of those interventions are much more meaningful than a camp placement, because I think the reason for camp placements is very often also historical, and there may be a lot of geographical constraints to that as well, I suppose.
Yeah, no, I definitely think it's the right starting point. And it is interesting in and of itself. But yeah, agreed. Yeah, and also being able to factor in existing locations and then kind of overlapping reach of kind of there's all sorts of interesting stuff that you could directions you could take it. Yeah, that's cool. Yeah,
I think one interesting thing that comes to mind now is also when you, for example, when you pick a camp location, there's of course the outputs from the simulation that may give a weighting to an objective, but there may also be constraints on the camp location itself, irrespective of the simulation that we should start taking along. I mean, Yanni mentioned during a meeting earlier this week that one of her camps ended up in a lake. I mean, that's a very obvious case where you might not need the simulation to figure out that one of the relevant objectives is not met. So yeah, there's a lot of additional context I think we can take along there.
Yeah. I know climate change is definitely a growing problem, but I don't think it's going to be quick enough to remove the lake from under the camp.
Yes.
Interesting.
So the second session, we have the first presenter, Nicola Papadopoulou. She is worked with us and collaborates with us within the Hidalgo project, and she is at National Technical University of Athens. Nicola, the floor is yours. If you want to share your screen.
Thank you. Let me share my screen. Okay, can you see my screen all right?
Yes, thanks.
Thank you. Okay. So yes, I have been collaborating with Derek, Diana, and the rest of the group in the context of the Hidalgo project. Just what Hidalgo is about in a nutshell, or some of its goals is to benefit from synergies between high performance computing, high performance data analytics, artificial intelligence, and all that in the context of challenges. So in practice, FLEE is one of the three Hidalgo, the refugee simulation is one of the three Hidalgo pilots, and this is where we use FLEE. And here's an incomplete list of the HPC aspects of Hidalgo. One of those is benchmarking and optimization. So what we do is we frequently benchmark code versions on the Hidalgo HPC systems, and we optimize the code. That is, we as a consortium. And we also focus on software code design and hardware software code design, which means that we try to adapt codes based on library capabilities and adopt new software features, and also study the behavior of different applications on new machines and architectures, and port code so they can benefit from those architectures. Part of the work we have done for FLEE within Hidalgo has been published this year in the Parsocial workshop in the context of IPDPS, and this is the first part of results that I will present today. FLEE is parallel, and it is parallel in two ways. So the first version of FLEE used agent parallelization, which distributed agents equally among processes. Locations were replicated across processes, and then there was a synchronization step for the population using MPI primitives. The newer version of FLEE also employs agent and space parallelization, which means that besides agents, also location updates are distributed equally among processes. Locations are still replicated. This means a bit more synchronization and a bit more communication. However, this version of FLEE scales much better to a much higher number of cores and a huge number of agents. This means that it allows for very large simulations. Here's a brief overview of the systems we use in the Hidalgo project. So two of the systems are hosted at PSNC. They are both Intel-based clusters. The second one, Eagle-2, is the newer version, and then the two other systems are hosted at HLRS, the Supercomputing Center in Stuttgart, and they are named HAWK and Vulkan. HAWK is the most exotic architecture that we have benchmarked so far, because it hosts those fat AMD ROM nodes with a very, very large number of cores. Vulkan is more typical, using again a newer version of Intel Xeon processors. Here are the results from these scalability scenarios of FLEE on those four systems. First, we have compared those two different parallel modes that I mentioned before, and then we evaluated two different scenarios. One is a microscale scenario and simulates the South Sudan migration. I think it was mentioned in a previous talk, I think, by Alireza. And the second one is a synthetic macro-scale scalability study of FLEE, which allowed us to evaluate those very large number of agents and very large location graphs. So here is what we've learned. Using a macro scale scenario on the HAWK supercomputer with 100 million agents on a relatively small synthetic graph, we have seen that this agent space parallelization used in the newer release of FLEE actually improves FLEE scalability This holds for all systems. Concerning this South Sudan migration microscale scenario, here we simulated the actual South Sudan location graph with a fewer number of agents. The simulation starts with 800,000 agents and ends with 2 million agents. You can see a scalability plot for all 4 systems. What we have found out is that these microscale simulations favor systems with moderate number of cores, but powerful per core performance. I will elaborate on that later. So this is because the microscale scenarios employ fewer agents, and there is not enough work to distribute when you use very, very fat nodes. But otherwise, FLI can actually make use of high per core performance. And looking at the macro scale scenario, here we simulate on a synthetic graph of 10,000 locations and 8 routes per location with a higher number of agents. You can see here as well that FLI continues to scale. I think this is the graph that refers to about 16,000 cores. We have observed increased scalability with the increased number of agents. The larger graph ends up to some decreased scalability. This is due to communication, but those macro scale simulations favor massively parallel systems like HAWK, which have a very high number of cores per node. So the takeaway message here is that this agent space parallelization scheme improved scalability, concerning those co-design aspects, for the microscale simulations, moderate number of cores and powerful per core performance are probably the best choice if you want to run FLI in parallel. And if you opt for macroscale simulations, then massively parallel systems can give you a performance boost. So here are very initial co-design scenarios that we have tested. We have 3 of them. First, we compare 3 of the 4 above mentioned systems in respect to their core-wise performance. In the second scenario, we compare the single node performance, and in the third scenario, we try to execute a certain scenario of FLI under a certain time limit to test the performance across multiple nodes. So here's what we have found out. The scenario includes 2 million agents on a moderate graph of 2,500 locations. So here's what we have found out. We compare 14 and 28 cores on 3 different nodes, those of Eagle, HAWK, and Vulkan. Eagle and Vulkan are different generations of Intel processors, and HAWK is an AMD processor. So Vulkan, which is the newer Intel node, showed the best performance for FLI, but with a lower speed up. The full node of HAWK, which has 128 cores, vastly outperformed the other 2 systems, but this is because of the massive number of cores per node. Then we compared the same scenario using the full node. And both the newer processors provide serious improvement over the older nodes, Intel nodes of Eagle, but still we found out that those AMD processors are more efficient for FLI execution and utilized better than those of Vulkan. And finally, we executed this scenario where we try to set a time limit of 600 seconds for this particular simulation and see how many nodes we require on each system to achieve this time limit and how many core hours we have consumed. So on Eagle, which hosts the nodes with a fewer number of cores, we consume more nodes and more core hours. On HAWK, we can get this very high performance with just a single node due to the best parallel efficiency. So we think that HAWK and massively parallel nodes are the best choice for FLI execution. So the takeaway message from that is that okay, the one size doesn't fit all holds. This is a common saying in the world of high performance computing. But for Flea, what works best is highly parallel nodes. It's not a particularly bandwidth bound simulation, and it can exploit massive amounts of parallelism on the target architecture. So next steps include targeted optimizations. We are working on profiling deeper this application on this hardware, and in particular we focus on computing peak flops and the cache and bandwidth utilization and communication ratios, and we opt for some software stack tuning, particularly on the Hawk supercomputer, which showed the best performance. So I guess that's all. Thank you very much, and if there are any questions, I will be happy to answer.
So I just had one question.
Hi.
Hi. It just came to mind that you know, so we had, this is an agent-based model and using a lot of computing power to simulate each of these individual agents. And so it struck me that, you know, right now I think the agents in Flea are, you know, the differences of agents are pretty minimal. So, but I imagine, you know, one of the key advantages of having an agent-based model is that you're able to have agents with different characteristics. So maybe just a comment for, you know, I mean, there's something for discussion later is that to take advantage of all this computing that's going on, that we would have a capability to characterize different properties of the agents. So yeah, I guess it's indirectly related. It just struck me as, you know, all the computing power and parallelization, to take advantage of that. You know, we want to have different characteristics of agents, if that makes sense.
It makes sense to me, but I'm not responsible for the functional parts of Flea, so we'll leave it to Diana and Derek to answer. So.
Yeah, no, Michael, I think your remark also ties in actually with Will's comment in the first half about ethnicity and age, for instance. Yeah. That seems to be a logical next step, to try and incorporate that. And then probably we'll also have slightly modified rule sets, possibly based on ethnicity, or perhaps the rule set is the same, but the pull factors are slightly different. So then you would have a bit more diversity in the agents. It's a very valid point. And I think what also ties in with that a little bit is that we actually find that Flea can work reasonably well, even if we scale down the number of agents at the moment. But I think if we make the agents more advanced and more diverse, that will start to change, and probably the code will become more accurate. Yeah,
that makes sense. I mean, I guess that wouldn't have, you know, having those different agent characteristics, that wouldn't have any effect on the parallelization itself.
Nikele, do you want to answer that one, or shall I do it?
I think it probably would, because you would definitely have to communicate more agent properties across processes. So that would limit your parallelization, and it would probably need a serious restructuring to the code to try and reduce that communication overhead. But yeah, that's just my opinion. So from my experience.
Yeah, I mean, on the other hand, probably the calculations required every time step would increase as well. So that might actually, so if you spend more time calculating, you actually improve the scalability. So there are sort of two effects in two directions.
Yes, you would probably definitely change the computation communication ratio. So yes, that makes sense as well.
I just want to add to that even like when we try to run small different types of conflict instances in our own computers, per different conflict, we have different simulation periods, as well as we do have the different number of conflict zones or the camps. So that also affects, for example, from our side when you running an instance. So by adding extra parameters or rule set changes, like you mentioned, Derek and Michael, that certainly makes sense. Thank you, Nicola, for your presentation, and thank you for the question, Michael. Thank you, Derek. So the next speaker we have, if you have any other questions for Nicola, please put them in the chat. So next speaker we have is Michael Puma from Columbia University. We've been collaborating with Michael and Kieran. Kieran, she's unfortunately on maternity leave, or fortunately for her, but it would be great to see her soon. But we've been collaborating for a while now. And Michael, you can actually start the presentation now.
Okay,
Thanks.
great. Thanks. Yeah, Karen will be back in a couple of weeks, so look forward to having her. And yeah, she's done a lot of work on this. Well, in the spirit of less is more, I think I'm going to focus on the first part in the title there, the use of FLE in operational setting, and I'll briefly mention uncertainties. And I speak slowly, so I would have been over time if I tried to do everything. But so this is the background. Basically, we've been working on a project called World Modelers, which is attempting to solve this problem of we have a lot of information about these complex systems that we have our data sets. So in this context, data sets on refugees, migrants, conflict, weather, all those data are available. We have our scientists or political scientists, policy people analyzing these with these complicated models. But then you have an analyst sitting, maybe at UNHCR or Save the Children or whatever, and they're not experts in specific domains, yet they need to be making decisions. And so what's this World Modelers project has been focused on trying to, there's a disconnect there. We have experts, domain experts in one area. We have analysts that are making decisions, and it's broken. Like this communication, there's a barrier of communication. And so the idea is that, well, can we improve our capacity to provide insights from these complex models and data sets to the analysts, but do so in a careful way where there's guardrails in place to make sure that analysts aren't misusing the data or misusing the models. So that's sort of the context of this. And so basically what this World Modelers project, which is actually ending early next year, is developing a suite of technologies to improve and accelerate the analysis of complex systems. So we go from very frustrated analysts who ends up because they don't have access to these data sets and the models, that they'll end up using Excel or just some very basic calculations and doing the best they can, which is what any of us would do in that circumstance. So the idea is, well, can we have a platform to help us? So there's two pieces of information that the World Modelers has focused on, is bringing AI technologies to text read, develop causal relationships that can be explored by an analyst, but then also this effort to bring in expert models and data. And that's actually what I'll focus on in this particular circumstance. We're talking about using FLE and trying to make that accessible to analysts. So this World Modelers platform, which will be, some of it's already publicly accessible. It will all be publicly accessible by the end of the project. Has two components. So again, sorry, just to be clear, this isn't the platform that was used for the AI text reading approaches. I'm just specifically talking about the expert models and data. So the first step, I know it seems a little mundane, but it's really powerful when you see how things are connected. Is a registration step, and that means that the expert or domain modeler, so the expert meaning Derek and Diana, would go in and, for example, they would register their model. Now, what does that mean? It means, well, I'll say that in a second. So step one is registering your model, and step two is explore and visualize. So the exploration and visualization is something that your analyst would do. The registration is something that your expert model would do. But why do you need to register? And I just took an example. I was talking with a colleague yesterday, and he's like, well, take a look at the Google Datasets platform that's now existing. I hadn't actually used it myself before. It's like, okay, if you type in migration, there's hundreds of data sets that pop up. So I just typed in migration, hundreds of data sets pop up. And the one challenge is that the data, the form of those data is anything. It could be Excel file, could be CSV file, NetCDF file, could be anything. And Google hasn't, that's a time-consuming problem. So at the moment they haven't tackled that. They just put all the data sets up, and there you are. But if you're an analyst, that you're left in a very difficult position because things aren't normalized. It's hard to deal with. Likewise, for a model, you can imagine all different types of models, all different types of outputs, very difficult to manage. So that's the idea behind this Dojo model registration. So that there's basically 3 steps involved. And I'm just sharing this with you because maybe it'll, spark some thoughts on, ways forward and future projects. So the first step is this model containerization. And basically what you want to do is recreate your modeling environment. So just take Flea as the example. We would go into this system, you download your Python, any libraries needed, you pull from GitHub, and then what this Dojo modeling system does, it will containerize or Dockerize that model, and then that means it'll be runnable in any future circumstance. And step 2 of this registration is that you annotate your parameters. So this is very interesting. So, experts in modeling Flea, you might say, well, what are the key parameters that you would want an analyst to have access to? So say there's an analyst that Save the Children, and you think that, okay, these are parameters that might change for this particular emergency, and you'd like that analyst to have the flexibility to change that parameter. So maybe it's the maximum move speed, maybe it's the closures, border closures, whatever it is, you would annotate that and you make it accessible. So you don't want every parameter to be accessible, because it just becomes, if you're not an expert with Flea model, how could you use that? Then you might misuse the model. So you expose the models that you would like to be exposed to an analyst. And then lastly, you have to define or annotate your inputs and outputs. So that's the one step. You register your model. Then the next step is to allow an analyst to explore and visualize the output. So what I mean by exploration is that you're able to either access different runs that have already been run, or you're able to run new simulations. And so that's the idea. Once you Dockerize the model, that an analyst will be able to run the model in the system. So for example, based on the previous publications from the Flea team, they've noted that the maximum travel speed is the model sensitive to that, awareness level, and move probability. So you expose these particular parameters to the analyst. And then also the description, you have to, one of the things when you're making it accessible in an operational setting is that you want this description to be in layman terms. And for non-experts, someone knows something about refugees, but is not an expert in the Flea model or any other model. So you have to have this sort of description documentation to make it accessible. And so there'll be some runs that were already run when you register it, but then also you'll want to allow the user to explore move speed for a particular range of values. So again, I mentioned guardrails. This is very important that you have particular guardrails on these parameters so that they're not, whoever's using this is not trying out crazy values. So it's really under development. So actually the last few months, we're very happy that this system actually started working because it's been certainly a bumpy road in this big project. But now we have something that's actually tangible, working. Basically, this was an example. We registered the Flea model for the South Sudan case, it's actually, it does run. So we're very happy, and you could pick different parameter values and it could run on the fly. Now, work needs to be done on the visualizations. Right now, we'll be able to have, well, they're working on having multiple time series, so 2 time series on one plot. Now, interesting point is like locations. This is something we'll be able to have the camp locations, but there's some constraints there that I'll point out. Well, I'll just point out right now. So the issue is that all of the data, because this system is designed for generic models, and there's limited time in the project, they made it working with gridded data and not network data. So Christoph, mentioned the sort of graph data, the travel routes data, and unfortunately, what's happened is that they haven't put support in to include the graph or network data, which is a real shortcoming, not only for modeling of refugees, but like transportation of food. Oh, sorry, transportation of food and other types of graph data. So basically, we have a workaround where we'll have camp locations for the flea model. It's just one of 20 plus models being registered, but it's not, we won't be able to gain the insights that we would hope to. If we're thinking about network connectivity, things like that related to refugee movement, we can't really do that. So we have a workaround right now, but the other good news is we're putting in a proposal to tailor this type of system to migration data and models. And the good thing about that is if we're successful, this Dojo platform will be further developed. The risk is with government funding, as many of you might know, right? You have your project, you have spend tons of money developing something, and then oftentimes it might not be used moving into the future. So we're hoping, if we're successful, to gain some funding to further develop this, maybe, and with more of a focus on migration and refugee movement. Just briefly, I'll just mention, so fundamental question, how do we represent uncertainties? I guess there's 2 ways to do that. So one of the things Karen was working on before she left, and she'll pick it up very soon, is doing this sort of Monte Carlo, Markov chain Monte Carlo simulations to understand how the sensitivity to parameters, so that you would have an envelope of uncertainty. So what we're hoping is that at least on some level, we would have multiple realizations input here into the visualization platform. So that's one hope. And Vitas, I forgot his last name, but Vitas had put up this implementation in EasyVVUQ. I don't know how you guys say that, but he put it up there.
That's roughly correct. Yeah, it's a really
okay.
good name.
I thought I could sound that out or something, but anyway, so anyway, it's in the system, and we're hoping to pick that up in the next couple of weeks. So basically, the other opportunity to put uncertainties is better documentation in this platform. So you would have some text here that the expert model would also register. And the last thing is that they're working on automated reading of the documentation for the model. So the GitHub repository, the publications. And the hope would be that you'd be able to pre-populate some of this, including the uncertainty information, and have it in some of these visualization, displays. So I don't know if I'm over time, but I'll stop there. So thanks. I don't know if there's time for questions.
Thank you, Michael.
Yeah.
Timing is perfect, actually. So is there any questions? We have 2 minutes.
Okay, Diana, I'll do a very quick question / remark, while others perhaps think of questions. So Michael, first of all, really interesting to see this dashboard. I think there may also be other people in this telco, but also outside, that would be very interested in knowing how you could use it and how portable it is. I'm just wondering, does the project have any type of sustainability plan if it doesn't get funded? This is always a very difficult thing, but I mean, I guess development would be limited, but would the environment stay alive, or can it be moved around?
So I've been harassing the project manager a bit on that point. So for me, I just emailed him. I said, listen, this system's looking quite nice. We don't want to lose it. So I said, can you give me a sense of the minimum IT requirements to maintain this moving forward? And then what I'm hoping is that, so even say that migration, we're putting in that proposal for migration, if that doesn't get funded, that I was going to go to some of the university donors. So, I mean, I think we could really pitch this to them and sort of foundation donors, and we might be able to sustain it that way. Now, I don't think that would be enough money to develop it further. That would require some new funding sources. But I think, you know, step one, let's get funding to maintain it. So yeah, I was sort of so he hesitated to give me the exact details. I think he wants to wait a couple more months, maybe the end of the year. But by the end of the year, I think we would have a sense of the sustainability. The other thing related to the running on multiple processors, that was a challenge, right? So like if you containerize your model, you also have to containerize that and specify the number of processors that you would have you need access to. And so that's, you know, that's some technical constraint that's very important, though. It will limit which models you can actually run on the fly. So, yeah.
Okay, great. Thanks a lot.
Thank you. Thank you, Michael, again. This is really interesting. Now our next, if you have any questions, please put them in the chat for Michael. Our next speaker is Samuel Wicks. He's a research fellow at Brunel University in our team. Sam, if you can hear and share your screen.
Yeah.
So Sam will be talking. Yes, we can.
Cool. Okay. Can you see my screen?
Yes.
Amazing. Okay, so I'll be talking about FLAIR, which is our conflict evolution algorithm. I'll start by just doing a bit of background with FLE. But FLE is something that relies on complete historical conflict data. And this means that despite FLE's predictive power, if a conflict were to erupt tomorrow, it would take a significant amount of time for both the conflict data to feed into ACLED, which is our conflict data source, and then for us to be able to use that with FLE. So for FLE to be future-facing and applicable to the conflict of tomorrow, we need to integrate a conflict evolution model which estimates how violence in a civil war setting evolves over time. In other words, we need to couple a model of conflict evolution to the migration model, and this is called FLAIR. Through this method, we move from a reliance on historical data to needing just the first few violent events. So we can take the first few battles or armed clashes, and from that, generate an accurate forecast of the rest of the conflict. So let's take a closer look at FLAIR. It has 4 phases of increasing complexity. The first one predates me, and that's fully artificial evolution. Here, Derek Groen and the rest of his team presented a prototype algorithm, which was based on adjacency. So in this algorithm, if a location was linked to another location, and that other location was in a state of conflict, then the chance of a conflict erupting in the initial location was multiplied by a base multiplier. The main focus of this phase, however, was not really on generating accurate results and more on just testing the coupled workflow and seeing how FLAIR integrated into FLE. So I took on phase 2, extrapolated evolution, as part of my bachelor's dissertation. And the idea here was to use ACLED data to find correlations from which you could construct a rule set for forecasting these conflict evolutions. So I'll explain what I've accomplished here further on, but for now, phase 3, which is what we'll be working on in the future, involves creating algorithms using external factors. So we spoke earlier about things like weather and anyway, we could use things like weather, demographics, infrastructure, all kinds of data, but the main point is that it's not the conflict data, it's data about the locations that's external to the conflict data. And then the final phase will be a sort of putting of everything together. So from the first 3 stages, if we find things that particularly work, or we find rule sets that are particularly accurate, we can combine these in the composite algorithm stage to have a sort of a meta rule set of individual rule sets that work. So let's have a look at what I did with my dissertation, phase 2. So there were 3 outcomes to my work. The first was the creation of an evaluation methodology. This enabled us to compare the results of one rule set to another. The second was a rule set elucidation methodology, which was a more systematic way of creating rule sets. And then the final outcome stems from number 2 there, and that's a rule set based on the population of a location. So the evaluation methodology asks 2 main questions. The first is a spatial one, and the second is a temporal one. So the spatial one is, how well does FLARE correctly predict whether or not a conflict will erupt in a location? And then the second question is, in cases where FLARE does correctly predict that a conflict will erupt in a location, how often does it get it wrong, essentially? So an example of that evaluation output is here. So it's in confusion matrix form. The first question is answered through the confusion matrix and the derived metrics of precision, recall, and MTC. And then the second question is answered through a basic error rate. Now for the rule set elicitation methodology, there are 4 steps to this. So the initial exploration of the data, then the selection of a lead. So what kind of data point gives us information that we want to explore further. And then there's the further exploration of that. And then there's the training of a decision tree classifier against the lead. So we use decision tree classification to build the rule set and then program that into our script. So this is an example of the initial exploration. So you can see here conflict indicator, which is whether or not a location experiences conflict in the simulation period, and then bin, which is which month from the start of the conflict it experiences conflict for the first time. So for instance, month 13, that's the 13 months from the start of the series of the period when we experience conflict for the first time. So looking at these, I mean, I derived a lot of these features are derived from the input files that we have. So outgoing links, incoming links, and total links. I extrapolated those from our input data, and I found that the standard deviation, which is the 3rd row down, wasn't very descriptive. So I focused instead on population, which had a very high standard deviation. So my thinking was that there would be a greater delineation between locations, and we could derive a rule set from that. So exploring that further, obviously you can see here, this is this conflict indicator. So 0 means there's not a conflict in this location, and 1 means that there is. So there was significant overlap between the 80,000 and 55,000 range, but beyond that, there was some room to potentially create some rules to isolate conflict. And then the same thing here for bins. And the thing that struck me most was that bin 21 isn't the 21st month. It's locations where conflict never erupts throughout the whole series. So it's a special bin. And I saw that as being quite low for the actual count, which is in this next slide. As you can see, the number of locations where conflict never happens is very high, but the population remains very low. On this one, sorry. You see the average population remains quite low, and it's quite low variance. So that led me to the following hypothesis, which is that any rule set derived from the population should have a higher true negative rate than the existing rule set, the adjacency rule set.
You have 1 minute.
So this is what this is the decision tree classification, which eventually turned into these programmatic rules here. And then if we just have a quick look at results, So that's the precision. So they're generally quite even adjacency and population, but I sort of confirm my hypothesis here in the sense that compared to the adjacency rule set, the population rule set was much better when it comes to predicting true negatives. Thank you very much.
Thank you, Sam. So if there's any questions, I would ask participants to put them in the chat, please. We're just gonna move forward with the next speaker. We have Nathan Wyckoff from Georgetown University. I'm sorry if I pronounced your surname wrong.
Oh no, that was perfect. Thank you.
There's a bit of echo at the moment, so I
Yes,
think I'm gonna
sorry,
mute
we're working
myself.
on that right now. Can you use the ethics? Okay, is it better?
Yeah.
Excellent. And you can see my screen, is that right? Excellent.
Yes.
All right, good day, everyone. I'm very excited to be here. Thanks so much. My group really appreciates the invitation. Very excited about the potential for FLEE. So my name is Nathan. I'm a postdoc. I just started here maybe 2 months ago. And I'm presenting some work that started way before I got here. And so these folks that you see next to collaborators did a lot of this work. And we're very excited to share it with you all and learn about potential synergies for incorporating FLEE. And so we're going to talk about a spatiotemporal Bayesian analysis of internal displacement. In particular, we're starting in Iraq, but we want to expand this framework to other countries and eventually multiple countries simultaneously. So in particular, the data set that I'm focused on right now to begin with is internal migration in Iraq in the period between 2015 and 2017. And our kind of ground truth for how many people have been displaced, we're using the International Office of Migration's displacement tracking matrix. And so this is what we're trying to predict. And we're making these predictions using traditional variables, such as what kind of religions are in a certain region of origin or destination, what's the infrastructure in those regions, as well as kind of organic variables. And we don't mean they're organic because they were made without pesticides. We mean that they kind of appear naturally, and we're using them in order to do our analysis. And in particular, we're looking at tweets in English and Arabic. And from these tweets, we're computing measures of sentiment or perception, of buzz. So this is, we've basically defined these topics in Arabic. And right now we're just kind of counting topics defined as keywords. So right now we're just kind of counting how often these keywords occur for this particular project, but we've also looked into more sophisticated approaches such as word embeddings, as well as events from event databases. So the goal is to try to combine these to predict internal displacement. And so what these data look like, I'm sure a lot of y'all are familiar, but in case you're not, so we've got these data that are over time and space. So here, for instance, we've got how many people are displaced from a particular governorate in Iraq. And this is during a period of the Iraqi civil war where, so this was during like the liberation of Mosul, which occurred in this governorate right here. So it makes sense that there's displacement in a Nineveh governorate, which is where like a lot of the fighting is going on. But there's also displacement going on in neighboring governorates. And this is the kind of thing that statisticians like to use spatial models for. And this data also takes place over time. So take any of these governorates, and you've got this time series line chart associated with it, right? So we've got spatial temporal data. And probably the standard way to, or one of the classical ways to model data like these, would be to use a gravity model, which just says, gosh, I cannot get this video. Okay. The gravity model just says the exchange, or in this case, migration between two locations is going to be a function of factors related to the origin of the migration. Like, is there, for instance, a buzz variable might be able to tell us that there's conflict going on or something like that. Factors related to the destination. So maybe you want to go somewhere where there's hospitals, or a particular religion is dominant or something like that. And origin destination factors. So factors that are pertinent to the pair origin destination. So kind of the classic example, and a gravity model would just be like the distance from the origin to the destination. But you could consider other things like, are the distribution of religions similar via cross entropy or something like that. So a measure that takes into account both the origin and the destination. And the classical gravity model just kind of adds these terms together. So from a mathematical perspective, it's really just a linear regression model, right? So the math doesn't really care that these terms were kind of inspired differently, although it's important conceptually. So this was our starting point, and there's a couple, as a statistical generative model, this gravity model says some things that just aren't reflected in the data. So we had to make a couple changes in order to make it fit. So the first of these is the fact that when you have data that are distributed over space and time, as these are, there's always a potential issue that your residuals are correlated, which basically could invalidate some of your p-values for your covariates, could make them smaller than they're supposed to be, which would be a big problem. So we're dealing with space and time in very standard ways. So dealing with temporal effects via an autoregressive model, in particular an autoregressive 1 model. And if you're not familiar, all that says is the amount of migration we're going to see tomorrow, or in this case, it's 2-week period. So in the next 2-week period is going to depend on how much there was in the previous 2-week period. And conditionally autoregressive models, the exact same thing, except for it's over space instead of time. So the residual for a given governorate, such as the residual in Anbar governorate, might, will, according to the conditionally autoregressive model, depend on the residuals for Nainawa and Salah al-Din and all the other, neighboring governorates. And so we take these terms and we add them to our model, right? So we've got, so now the model that we've built is the amount of migration that's going to occur as a function of this classical gravity model style covariates, plus a temporal term, a spatial term referring to the origin, a spatial term associated with the destination, and then this temporal term. And all this together, I'm just going to call mu for short, because that's what statisticians like to denote means by. And okay, so far, start with the gravity model. Now we're taking into account space and temporal residual correlation. Another thing is the fact that a standard linear model like this implies that its domain is just the real numbers, but that's not the case, right? The amount of migration between two areas has to be positive or non-negative, and in particular, it has to be a count typically, right? So a common thing to do in gravity models is to take like the logarithm of the response, which is fine. And we're just going to do something slightly different instead. We're going to explicitly account for the fact that our data are counts by using a distribution over counts. And we've chosen the negative binomial because that's a very popular one. And it's very similar to the Poisson, if you're more familiar with that one, which basically just lets us estimate mean and variances of counts. And so the mean, right, as it always does in regression, depends on our covariates and also on our spatial effects, as we just saw in the last slide. All right, there's another aspect to the data that's not yet captured by the math that we've gone over, which is the fact that there's tons of zeros in the sense that over most time points and spatial pairs, there's no exchange. And so we're dealing with that via zero inflation, which is a very classical way to deal with these problems, which is where you take whatever our distribution was. So what I defined in the last slide, this negative binomial one, and you say, okay, instead of my data coming from this, this distribution, what we're going to do instead is we're going to flip a coin that's biased. And if the coin comes up heads, which it will do with probability rho, which is something you estimate, then there's no question about it. There's just no migration between these two places at this time point. But if it comes up tails, which it does with probability 1 minus rho, then that's when you sample from the negative binomial distribution that we were just discussing, incorporating the covariates and the spatial temporal terms. Okay, and there's one last thing that we've considered so far that's present in the data that's not well captured by the gravity model or the modifications that I've discussed so far, which is the fact that there's effects between time points. So what we're looking at here in this graph, the red solid lines are some of our buzz variables in Nainawa governorate over the time period. And the dotted blue line is the that IOM IDP DTM data I was telling you about. So this is the number of displaced families over the same period. And what you notice is that if you want to use the buzz variables to predict the displacement, there's definitely a relationship here, but you can't just use the buzz variable associated with the time points when the migrant arrives and is counted, right? There's clearly a delay here. So, so lags is like what we call this in statistics. So we want to account for the fact that the displacement at a particular point can depend on covariates at previous time points. And we're just basically, so see this tau here, that's telling us how far back do we need to look effectively. And so we're just estimating that in a standard Bayesian way. This is something that's a little bit more ongoing than the other, so to say, corrections. So what's really great about these Bayesian models is that if you can write down the math, then at least theoretically, you can do the inference without any real effort. There's all kinds of libraries. So Stan, Bugs, and Jags are probably the most popular ones that do Bayesian inference automatically. So we're using PyMC3, which is very similar, stands for Python Monte Carlo version 3. And just like these other packages, Stan, Bugs, and Jags, all you have to do as a user is plug in the math from the previous pages. You just type it on your computer, and then it will do Bayesian inference via some kind of MCMC. In this case, PyMC3 uses a gradient-based MCMC approach. In particular, I think it has several, but the default that we're using is Hamiltonian Monte Carlo plus the NUTS proposal. And the only thing I want to mention about this framework, which is kind of nice, is that it has automatic differentiation, which, if you're not familiar, automatic differentiation allows you to figure out for some small perturbation of your model parameters, how does that affect the model output? And it's what's enabled deep learning to happen, basically, and much of other machine learning as well, is automatic differentiation. It's extremely time-saving when it comes to complex models. And PyMC3 uses Theano's auto differentiation. Theano is I'm sure I'm not saying that right, is a deep learning framework. It was a competitor to TensorFlow, if you're familiar with that, but it has since died. But it lives on in PyMC3. Okay, so takeaway from this slide, gradient-based MCMC is kind of the popular way to do inference on these continuous models these days, and PyMC3 enables that. Okay, so as was mentioned, so we're not directly using FLEE yet, but we're absolutely interested in potential synergies. So this is, I was already excited about FLEE before this workshop, and we've heard such great presentations from you all. I've already gotten more ideas than what's written on this slide, but what I had a priori was this idea of maybe making the coin three-sided. So thicken the side of your coin, and then if the coin is heads as before, output is 0. If the coin is tails, output is from a negative binomial. And maybe you could have some kind of like switch from a statistical prediction mode to like a more precise agent-based mode. So if some significant event happens, potentially you could bring in the FLEE model to deal with that like complex event. And when it's more like kind of the background amounts of migration, maybe at that point it's okay to rely more on like statistical coarse-grained approaches. So that's what I was thinking before this, but I'm very interested in hearing if you all have any suggestions. Something that came to mind during William Lowe's presentation is that maybe instead of it being like it's a big event is what switches on FLEE, maybe it's when you don't have enough data that you want to move from the statistical data-hungry model to a more agent-based approach, or something like that, based on like if the Bayesian model is very uncertain about the prediction, right? Maybe that's when we want to bring in FLEE or something like that. Okay, so very interested in potential synergies. And I wanted to mention really quickly, so this is absolutely still work in progress, but I just want to super quickly go over some results that actually precede me arriving at this group. So, but here we're looking at, instead of predicting exact migration counts, we're looking at predicting whether like a big migration event occurs or not. And one thing that we found is that, so death here is something that like in our data set does appear next to migration counts, but in real life you wouldn't get until later. And it's obviously very correlated with the amount of migration that's occurring. So we're really excited that by bringing in this buzz variables, we're able to get our accuracy to approximately that of when you're using this kind of cheat depth variable. Okay, so just to recap, the goal is we want to do early warning, predictive migration using open source and traditional data blending. If we have all of our time points lined up correctly, it seems like the organic variables lead migration reporting, which is useful, of course. If you're interested, check out our project website. Here's a URL for it. And we're also, via this website, sharing our buzz variables. Just shoot us an email if you're interested in getting your hands on those. And the next steps for us are to do additional case studies, in particular, Venezuela and Bangladesh. Like I mentioned, very interested in incorporating ABMs such as Flea. But ultimately, the goal is to have kind of a unified, maybe even global scale, but certainly multi-country migration framework. All right, thank you so much for listening. Feel free to shoot me an email if you have a question, or you can just ask it right now.
Thank you, Nathan. If there are any questions, we can actually take them, because our last speaker, unfortunately, sent me an email saying that he's not feeling well, so he won't be able to present. So we have time. So if there are any questions, please unmute your microphones and ask Nathan.
Nathan, I guess we will have a bit of time for questions then. I was just wondering, you mentioned about using the Bayesian inference approach, or basically Flea as alternative approaches. But then also in a different part, you spoke about this peak in buzz and then followed by the peak in migration. And at the moment, you're trying to find the parameter of the delay in the two peaks. But of course, the delay in the two peaks could have to do with the kind of route that migrants may be taking, or the way that they move, or how rapidly they decide to move. So I guess, would it be possible to use an agent-based model to try and figure out what that delay could be?
Yeah, that's a great idea. I don't see why not at all. Yeah, you could potentially, so I understand that there's free parameters in this model, so potentially you could kind of combine both approaches. Maybe this is what you're suggesting, where you would like actually learn the Flea's parameters such that the gaps that it implies are those reflected in the data. Yeah, that makes perfect sense to me.
Okay, it would be interesting to explore that. Yeah.
Yeah, good idea. Let me get that down. Because it is absolutely like a vital part of it. And yeah, you're right. There's no reason to believe that that's homogeneous throughout, time or the world. So yeah.
Any other questions? I just gonna add from myself is that I got to know about Georgetown University and about their work recently, thanks to the IT Flows meeting we had in collaboration with yours. And I was quite impressed with what you've done so far. And I think it's a good collaboration network that we can actually establish in this time frame that we have, Derek.
Yeah, I agree with that. So definitely, we should explore this further as well. Yeah, I agree.
Absolutely. There's absolutely interest on our side as well.
I just add, sorry, just quickly, because one of our collaborators, Manu Lal, who's in Columbia University, the engineering school, he's done a lot of work on Bayesian inferencing, and we've been having these conversations on how to inform the parameter selection for the Flea model, and we sort of we made a decision to go with MCMC, but there's still a lot of interest in discussing the Bayesian approaches. So yeah, maybe you'll be in touch on that point.
Absolutely. Are you talking about computational approaches such as like MCMC versus like variational Bayes, or what level are you?
Well, I think I guess that, yeah, Manu Lal is. I think he has this. He wanted to take a step back and try out some. Well, we were thinking to interpret some of the output from Flea with some Bayesian approaches. So yeah, I think there's a lot of different avenues that maybe I'm not so much the expert in Bayesian approaches myself, so it's a little I'm on the learning curve for those approaches, but maybe we could set up a conversation at some point.
I would love to.
Yeah, what I recall that he was trying, and it was Kieran, they were trying to understand the simulation output we get for each camp and how they're actually different from the actual data.
Yeah.
Gotcha. Yeah, that's very interesting. And definitely Bayes has some really cool model calibration tools. My PhD research was in like computer simulation stuff, not quite calibration, but I'm aware of these very, very exciting tools to do exactly that.
Thanks.
So I guess this is the end of our invited speakers talks, as well as presenters from Brunel. Thank you all for your presentations. I hope the audience enjoyed all of the talks. And we have the next session, which is a panel discussion. And we have very important people actually in our workshop that I think will love to share their opinions, insights about FLI itself, as well as how we can use and we can move forward.
Hi, everyone. I hope you've all had a good break. So we'll now continue with the last part of the workshop, last half an hour, basically. And during this part of the workshop, we'll have a panel discussion. Of course, the talks today have been quite wide-ranging, both technical, humanitarian, theoretical, but also very applied with scalability. And with our panel, we similarly try to find a group of people with very diverse backgrounds. So I hereby invite everybody who's in the panel to turn on their camera, if that is possible. And let me just briefly introduce the people we have on the panel today. So we essentially have 5 panel members. Several of them have been speakers today, but 2 of them haven't. And I will ask them to also give a bit of an introduction themselves. The 3 panel members that you've already met before are William Lowe from Save the Children, of course, Michael Puma from Columbia University, and Yanni Shui, who is a research fellow in many objective optimization here in our group. In addition to that, we also have 2 other guests who are willing to take part in the panel. One of them is Rebecca Moreno Jimenez from the UNHCR. Rebecca, can you hear us?
Yes, guys, I've been here since an hour ago, so nice to meet you all. It's just been, I was in another webinar and then jumped in this one, but I managed to hear 2 of your presentations, so very interesting to know what the academic sector is doing.
Okay, very good. Well, we've made recordings, so you can always watch back the others at a later date if you like. Do you want to introduce yourself very briefly?
Sure. Nice to meet you all. So my name is Rebecca Moreno. I'm the lead data scientist for UNHCR Innovation Service. Been in the service for approximately 6 years, and our role is to foster innovation, specifically in our team. So we have also Sophia and Catherine, I think, in foster innovation in data, new approaches for data capturing, data analysis, and data visualization. And research is focused mostly on big data analytics and artificial intelligence. So nice to meet you guys.
Okay, great, very good. The second new member of the panel that we have is Anulekha Nandi, and she is a PhD student at the London School of Economics. And she's in a very special position because essentially our research group is her use case for her PhD. So she studies the way that we do our research around building migration simulations, but also interacting with other organizations and trying to bring things into applied practice. Anulekha, can you hear us?
Yes, hi. I'm going to try my camera.
Yes, it works.
Yeah, okay.
Yes.
Perfect. Thanks.
Would you like to give more detailed introduction as well?
Yeah, sure. Thanks so much. You've introduced me quite well, and you've summed up my work very succinctly. So like Derek said, I'm a PhD researcher in information systems and innovation at the London School of Economics. And I am trying to understand the organizational processes, interdependencies that go behind digital innovation in the humanitarian sector. So that's primarily my research. And in my previous experience, I've worked in the development sector in India on ICT4D and digital rights. So that's kind of my professional background and where I'm coming from. And I'm happy to be here. Thanks. Thanks so much.
Okay, great. So the structure of this panel discussion is essentially that we've selected 4 questions in advance that we'll propose to the panel. And that you can shed your light on. But in the process, if anyone in the audience wants to ask specific questions to the panel, please put them in the chat, and then I can always shuffle out some of the prepared questions for one of those questions. And if we have time remaining, then we can always have an open discussion. But I think since we have half an hour, that will probably fill it quite well. In addition to that, we also prepared a very short survey with those 4 questions that we already prepared. So that not only the panel can provide their thoughts about it, but also you as audience can share your thoughts by putting it in the survey. And then later on, we can basically share the main conclusions from those questions.
I'll share the link for the questions that you can fill as well in the chat now.
Okay, very good. Thanks a lot, Diana. All right, so to sort of start a discussion a little bit, the first question that we have is basically for me to the panel is what today is possibly the most important humanitarian question that FLEE could actually help to address? Is it one of the questions that we had in mind at the start, or is it a different type of question? So does anyone have particular thoughts about that in the panel?
I can jump in early.
Okay.
I think as I kind of touched on in the presentation earlier, I think our kind of primary frame for this is a resource allocation question, which is, I think, is a good way to frame it, because it's something that in this space is actually kind of a good way to kind of simplify what is a very complex space, a very complex problem. This is about resource allocation. This is about helping agencies like SAVE to know, where people are going to be with, and what needs they're going to bring with them, as defined as some of the things we talked about, demographic characteristics, age, gender, this kind of thing. So anything that kind of narrows down that space and to helps us allocate our resources, because this is a sector in which, resources are limited, and, we are trying to meet these needs in the most efficient, cost-effective way possible. And we've seen today, there's all sorts of other aspects to it beyond that kind of simple framing. We've touched on kind of travel corridors and location of potentially supporting infrastructure outside camps and whatnot. But at the core of it, I think for me, I kind of return to that. This is resource allocation.
Okay.
Go ahead. I could jump in and comment. I mean, I think that's a great point. And, one of the real emergencies right now and pretty much disaster that the world's facing is the situation in Afghanistan. And it strikes me that, for example, a tool like FLEE is useful, and to this point about resource allocation. If World Food Program is involved in a region where you have various actors, various troubling actors as well, that it could potentially be a very valuable tool for them to explore different options. So I've been, one of the things that I've been grappling with is, well, World Food Program, and they've been on Twitter like emphasizing that they when there's a need for food, that they're sort of a neutral party, and they don't get involved in the politics. I'm stuck there though when I see that, if we think that, I feel sometimes that's somewhat simplistic in the sense that, well, it is a question of resource allocation. So if for example, World Food Program prioritize allocation of food to, say, refugee camps around Afghanistan versus providing food within Afghanistan, what are the different range of outcomes? So it's just curious for me, and maybe it's opportunity for institutions like WFP to examine in a bit more nuanced way how they can use their resources.
Okay. Rebecca, from your perspective, do you also feel it's largely a resource allocation problem that we could tackle with it?
It is and it's not. I think it's bigger. In our case as UNHCR, I think the most important question is the outputs. So there's obviously things for the model, which is the data in itself and the inputs. And the models usually unveil a huge gap in humanitarian agencies, which is data collection, right? And the quality of data that we have. And then the outputs, there's even ethical, or I would have to say Monday questions was like, should we actually predict in the first place in some places that you know that they're gonna be closing, I would say, migration pathways or asylum in case there's results that could be public or I would say in the wrong hands, if you wanna call it, but it's not the wrong hands. Actually, there are some very public actors that want to know how many people are gonna arrive into their continents for them to close the borders, right? So I think that beyond how many people and why are we gonna serve them for is like how we protect them first. And maybe a resource allocation for, I would say, humanitarian assistance or shelter, that's the how you protect. I think the bigger question is how do we protect? Is that maybe the how on resource allocation? Yes, of course, that's a how. But also the how could be if there are certain people are gonna flee into certain area that probably are gonna be more at risk from one continent to the other. That's also how, right? So it's not about in the other case they want to eliminate resources or put surveillance into them or actually just deter them for coming. So it's also an advocacy part, which is not only on resources. Is sometimes these tools are better, and we were working a bit on predictive analytics with Brazil on shelter capacity. And what we have discovered a lot of lessons learned from Jetson and Somalia now with Brazil is that they are not interested in itself on the numbers of the accuracy. They're just interested in a general understanding for them to be able to advocate with the government. And it's like, might be coming that it's X, Y, and Z, but actually we are thinking that it might be in this range, which is not even an accurate thing. And we want shelter for them, right? So, and then the question of resource allocation coming afterwards. It's more for first creating that avenue or that advocacy channel to, I would say, very big stakeholders, governments, counterparts, for them to be able to later on maybe decide, maybe it's not the UNHCR in our cases, but maybe the governments or other humanitarian agencies that are doing that. But first is to open the conversation on like, there's info of people that might be arriving or not. And so what do we do and how do we do it, right? And then resource allocation, of course, is one of them, but there's many other questions. Yeah.
So the size of the migration is very important then as well, I guess. Yeah. All right. Is there anyone else in the panel who would like to provide their thoughts on this question?
If I might add, it's also, I think, a question of how the problem is represented. You know, I mean, which aspects of the risks are factored into the model, and also who the users are in the organization, because a lot depends on attendant infrastructural as well as professional capacities. And which is, I mean, that's how uptake is determined. So I think, you know, who the users are essentially and how the problem is represented within the model, and that translation into organizational learning. And I think this point was raised earlier that, you know, just to be aware of how to interpret the model. So probably there is not a willful act of negligence or adverse use, but just to understand the constraints of the output itself and how that then can be translated into operational use, perhaps.
Yeah, I think you touched upon a very important point there. That's simulation produces results, I guess, but then what is being done with the results? How do people view the results, and what are the aspects of the results that people take along in their decision making? I mean, to put it simplistically, obviously the raw number itself doesn't have infinite accuracy, so that alone can't be the guiding thing. But then, yeah, the relation, I think Rebecca alludes to that as well. The relation between what the forecast says and how the decision is guided can be quite indirect, I suppose. Okay, does anyone else have any thoughts about the first question, or perhaps anyone in the audience? If not, I'll shift gears towards quite a different type of question. This one is very concrete, but I thought it might speak to both more technical people and humanitarian people alike. And it's essentially, what change or addition would you like to see in FLI tomorrow? So we wouldn't sleep tonight, we would implement it immediately. Does anyone have particular thoughts about that?
I'd like to be able to run it. I'd be very curious.
Okay. Well, that we could actually do in one night.
Maybe include other type of, I would say, non-traditional data sources, because that could be or show sustainability for other operational context. Now, I know that you guys have historical data, and I know it's very contextualized already because AVMs are supposed to be contextualized and with situation, but maybe if behavior is not coming directly from refugees or IDPs in itself, are there any other proxies? And I know it's a huge assumption, a huge risk to make on, I don't know, you're gonna utilize other sources like social media and stuff, but in some cases, as we're seeing with Venezuela case, this is actually something that is very common, like the use of WhatsApp or the use of Facebook, which is huge. So maybe how can we readapt it to other operational contexts, for example, with high connected operational context. And then I guess you did a super cool case, because in your case, you were going for the low connectivity, no broadband, no nothing. So it's actually raw behavior, but it seems to be that in other operational contexts, there's other proxies for behavior. So that would be interesting just to know in general in the future.
Okay, yeah, I think that is a very interesting point. Actually, within the IT Flows project, we have a bit of an avenue to try and explore that, as there's also within that project, there's another institution that does some of this social media analysis. I'm not sure we can get it in tomorrow, but we can definitely pursue that line of research. Absolutely. Does anyone else have thoughts about this particular question, what to add to FLI?
I would just say, I guess I said it before, but I think if we can distinguish between different types of agents and sort of have at least some rudimentary characteristics along ethnicity. I know it's, yeah, one has to be careful with that. I mean, already we have, you have 3 parameters where the model is sensitive to, so we don't just want to add complexity for complexity's sake. So, but yeah, I guess some capacity to distinguish agents. The other thing, somewhat related to what Rebecca was saying, I mean, I think one of the things is if we can characterize the uncertainty in the observations. I don't know if there's some, I mean, right, those UNHCR observations that FLI's always compared against, those are usually uncertain. We don't know the timing when the data is collected, and we've talked about some of these issues. So I don't know if there's some way to, I mean, because the observations are included in the output, but is there some way to, I don't know, have a uncertainty bracket around that or something like that? I don't know, just some thoughts.
Okay, yeah, no, that's, yeah, I think the ethnicity and also the age-related aspects are high on the agenda, I think, especially after this workshop. In regards to the uncertainty with the data, well, I'm not sure if Rebecca can shed additional light on that. I think from my side, what I do know is it is possible using certain distributions to sketch uncertainty, given that you have limited number of data points in a synthetic way. But there may be much more superior methods to do that.
And I'm gonna point out, I don't know, Geraldine, because she's the statistician from UNHCR point on data science team, on more complex methods. I mean, we have done everything and anything whenever we have huge gaps, especially COVID-19 actually was a lot of the models that we were very affected. So we did at some point have a ridiculous thing of imputation by median, then drop it, things like that, because 1.5 years of missing data is very bad. But yeah, I don't know. Geraldine, are you there, by the way? I don't know if she's there. Stats team of UNHCR. Perhaps it's there, but not there. Anyway, yeah, I would say that there's more, I would say, sophisticated methods. We have done probably the least sophisticated things. At the end, I think I agree with Michael on that one, and it's good to point out, like, sometimes what we care is about the most vulnerable, and so maybe disaggregating a bit the agents into, I don't know, age brackets if possible. I know you have done it also to gender, that's also nice. but then insert a particular situations also to see if they have extra information for vulnerabilities, because that's something that we're super interested in general. But yeah, no, I don't think I have an elegant solution for missing data.
All right. Yanni, in your case, you've done, well, 6,000 simulations for your many objective optimization exercise alone, if not more. Do you have a particular feature request that we should urgently implement in Flee?
Yes, I think to make our model more, have more features, and I think we can consider some other requirements or perspective from NGOs or governments. For example, because we are dealing with the problem of camp location selection, so they may have limited construction costs. And also the transportation costs. We may consider, and for the refugees' point of view, and I think we may consider, their requirements, and for example, except for the food and their safety, or what's their their thought about the safety and the I think yeah, and we may also consider how they transport from one place to another place, because not every agents work or using a bus to travel from one place to place, so it may cause different uncertainty result. Yeah, that's my concern.
Okay, I think you touch upon a very interesting point, especially in terms of the camp placement. So if you establish facilities in support of refugees, then of course that comes with associated costs. And I guess in some areas could be more efficient than in others. So that is, especially when you start making strategic decisions, those are factors I guess you should take into account as well, particularly if you do the optimization using an automated computer algorithm, rather than just manually weighing off the various options. I'm just saying for the chat, Ali Reza also raised a very valid point, where basically, a lot of people are not displaced to camps, but they may end up in other places, in cities, or perhaps even in the countryside. So it's very important to take those situations into account as well. And I guess that too would require some modification of Flee, because, well, to put it bluntly, the countryside is not really represented in a location graph. So that's an important aspect to take along as well. And then I see Michael's comment in the chat as well. Is there a straightforward way for users to implement a new blocked pathway? Yeah, that is actually in the code. How straightforward it is? Well, it is modifying a line of Python code, but you still have to modify a line of Python code. So perhaps there could be simpler ways to do that. I believe in CSV files, it's also possible in a static manner, but there too, we can make improvements, I think. All right, I'll move on to the next question. And I think, Will, you might have a say or two about this. So my next question is basically whether there's a case for researchers to design and manage migration forecasts in an operational context. Is this something that researchers should be doing, or should researchers steer well clear from that and leave that up to the operational professionals?
Yeah, thanks for a nice simple question. Yeah, I think this is a very live question for us at the moment, trying to work out how we kind of meaningfully work out how we're going to be able to kind of in-house a lot of this activity in an organization that it does not kind of have a wealth of experience with data scientists and kind of operating in this space, but absolutely kind of need to work out a way to do it. So to be honest, I don't really have an answer. I don't know what the answer to this is yet, and I think it's something that Save the Children is kind of really wrangling with at the moment, as we kind of look towards a much more kind of digital future, but doesn't quite know the route that it's going to take to get there in terms of internal resources, in terms of the capacities and the kind of team structures we need. It's like there's everyone knows there's this thing bearing down towards us, but no one's quite sure quite how to deal with it. But yeah, there's a lot of focus on this at the moment internally, which is something that, we feed into. But yeah, I honestly don't feel like I have the answer for this yet. And it is a very live debate.
Yeah, it's a difficult matter. On our case, I mean, I'll just chip in a little bit myself, but from personal experience, the COVID-19 pandemic was very sudden, and we got approached by the NHS to do modeling. And what we managed to do within our department was mobilize quite a lot of lecturers, research fellows, etc., to suddenly start working on that. And I guess part of it is perhaps the ethical, moral, legal, political aspect of it all, like should researchers be doing it, organizational or operations people. But the other aspect is also the practical aspect, which is when a crisis hits, you usually have very little time to ramp up forecasting, modeling, development effort. And how do you find a way to effectively ramp that up? And I guess in the case of COVID, it was very often voluntary effort because funding simply doesn't stream quickly enough for people to immediately handle a crisis. But yeah, it's very interesting. I'm not sure if other people have certain thoughts about it as well, one way or the other.
I think I will jump in because I work with a lot of operations. I think it's not either you or them, it's both. Because they don't have capacity, they don't understand models nor performance metrics. They just want to serve and serve them quickly. And so if you are able to build something that is user-friendly with them, and that they can manage themselves, and then they can run at some point, then they will run it for you, but they cannot build it. They're actually busy trying to run COVID tests for people that are just fleeing, and then trying to put the shelters, negotiating with the military not to push that people. So obviously they're at strain, and there's even two or maybe sometimes there's usually one or two that are super interesting, and actually the data analysts, IM officers, what we call information management officers, that are willing to learn, and you need to have dedicated, I would say, time to train them, to show them how the tool works, and then to see if that tool could be integrated with the data sets that they have, et cetera, et cetera. And also that's one. If we keep doing that for ourselves, you're creating like a codependency with them, which is something that we experience a lot with Jetson. And so you try to build is something that they could deploy with little knowledge or like a front-end application. I know that a lot of the things that we build is back-end, and believe me, humanitarians are not good in coding just yet. There's just very few specialized at field operational level. So something that they can easily use, and then that it can be easily tweaked in case the operation changes, because as you said, with COVID, things change. Like for example, when we started the project with Venezuela, COVID was just happening and there were some measures. Now COVID has another measures, and the border was reopened, but it's partially reopened. So the rules of the game don't apply, they're always changing. And they need to be changed quickly. So you need to have this kind of modular approach whenever the user can change things on your behalf, even though the main backbone. So it's building with the user together and then trying to transfer that knowledge that you have. And I guess you lead the innovation research, of course, and trying to do new things. But then you leave them to implement your tool for them to be useful. So it's not, you guys should be driving it. You should be driving the innovation on trying to find new things to do things. But then the ones that should be leading is the operation on because they understand what that tool is useful for at some point. But it's a co-design kind of thing, I guess. I don't know.
Okay, yeah, no, that does make a lot of sense. And sort of bringing the barrier to use down, and at the same time, making sure that people in operation actually have the bandwidth and the room and the time to do it. That's a very important challenge. I saw from the audience, Anastasia, a colleague of mine, who is also a senior lecturer, also wanted to say something. So go ahead, Anastasia.
Yes, hi, Derek, thanks. And thank you everybody for the very interesting workshop. Just very quickly, because I think Derek, it falls into all the comments that everybody said, really, and what you said earlier about the work we did for COVID, because I was thinking all the problems of cost and resource allocation and an easier way, perhaps for organization as well, to structure the resources, and it is perhaps to include hybrid simulation, and together with FLEE, we could connect a discrete event simulation of organizing a camp. which is a little bit of, it is a modeling technique that usually organizations understand better, how the process is flowing within their camps and how they organize the resources. And together with the prediction of movement of people to the specific camps, we could perhaps have a more comprehensive system. Just a thought.
Okay, yeah, that's a very good suggestion. I'm not sure if in the remaining 2 minutes we can get people's thoughts, but yeah, perhaps if people have thoughts, please do share it with us, because that is a track that we can take forward, I think. All right, I think with the last 1 minute remaining, I guess, there is a fourth question. And the fourth question is basically, how can we best involve the input of migrants themselves in the development of FLI? So far, the input has been quite indirect, because we don't like to use personal data if it's not strictly necessary, but it creates this weird dichotomy where we want to look after the refugees because we don't want to use their personal data and abuse that in some way. But at the same time, we may be able to help them better if they gave us more feedback. But then there are also all sorts of legal constraints. So I think for me, and I might speak for Diana as well, we find it really difficult to figure out, okay, how can we incorporate the inputs from migrants themselves? I'm happy for anyone to pick up the question if they have any thoughts about it, to be honest.
Quickly on this one, we did it with an AVM for Bangladesh. So it's UN Global Pulse. I think our colleagues needed to jump into another meeting, but Joe would actually ask. So we asked the operation, because they were locked down, refugees themselves were locked down, and the operation was locked down. So we asked them to go to certain home visits to request data that later on they included in the UNHCR microdata library. They just did a survey in Kobo on how many times do you go to they wanted to do an AVM for COVID pandemic spread, right, in the camp. That's what we did. Just to understand the behavior, how many times do you go to, I don't know, a latrine? How many times do you go to the shopping center or the market? And like, how many people do you visit? Or how many houses do you visit, just for us to understand? And the operation did it for us. And they were saying, why are you doing this interview? And so we were fully transparent with them. The Rohingyas are illiterate guys, so it's very, very well, the consent. And it's like, well, we're trying to see how to protect you from COVID, and where could be a spread, this, like, you know, what could be the spread? Maybe it's the distribution center, maybe it's that. So when you explain that is to help them, they will cooperate. Like, it's about like understanding, like, okay, so why are you asking me this question? We want to actually see, maybe we can build better shelters, or we can distribute food. I don't know, whatever the aim of FLI at the end is for that operation. And I think they're willing to share and disclose that, as long as you do the full consent of the ethical part of the approach. And then you are very transparent on, like, we're doing an application that is trying to say, like, what city are you going to choose to be a urban refugee, or what camp, why are you choosing this camp to make the camp more safer, etc., etc. Hopefully this will inform. I think, like, you and me, like, refugees are very, very willing to cooperate. Sometimes when they're waiting in the charging station, or like when they were in the border, it's a good time. If they're not stressed trying to cross, of course, but sometimes they're just waiting. And as long as you're transparent with them, you can also coexist. I think it's super useful just to get their insights, and something that we learned from the Bangladesh simulation. I'll put the link there.
Okay. Oh, that sounds extremely interesting, and in a way it sounds more doable than I guess I have as a perception in my head. Anneleke, do you have a particular perspective, perhaps from your experience, from the academic perspective?
I think, yes, I think there is that question of, we are kind of trying to model a very complex reality, and trying to abstract a very complex reality into the model. And we are trying to approximate decisions based on experiences of operational staff or programmers, like computer scientists like you. And I think, you know, people who've actually made that journey can contribute better in many ways to the representation of the problem. But yes, I mean, it is a significant challenge, because during COVID, there was large-scale internal migration in India after the first lockdown, and we didn't know how to deal with it. And a lot of whatever each NGO was doing, they just stopped, and we started doing relief efforts, essentially. I think, like Rebecca said, like, at times you just cannot ask certain questions because there is the stress of trying to feed themselves and, go back home or find shelter and just be safe, essentially. So it is kind of, trying to strike a balance between what is feasible and what is kind of just like having that bit of sympathy and empathy, essentially, that, you can't ask certain questions at really stressful times, even though they might contribute significantly towards the objective at hand. So I think it is that balance that we need to be kind of careful about and leave it to the, decision at the ground level, because they have a better understanding about how to negotiate that space, I think.
Okay, yeah, so I guess, among other things, the timing is also very critical, and I guess the kind of questions that we would formulate. All right, I would thank you all very much for taking part in the panel discussion. Also, thanks a lot for the audience for sharing the questions. In terms of the workshop wrap up, I will leave it very short because we're overrunning slightly. But I think when Diana and I set out for the workshop, we had a certain expectation, and the response we've gotten surprised us both. So I'm really thankful for all the different, for all of you showing up and contributing your bits to panel discussion, to the presentations, and also to see the wide range of work that has been going on FLEE, even though the code didn't exist 5 years ago. I think it's extremely impressive. Of course, the big question is how to take it forwards, what next steps we will take. And I think this workshop has been very useful in trying to identify practically, like, okay, what should we focus on in terms of code in the next few months, but also more on the longer term, like, okay, between which groups could there be potential collaborations? I see, for example, something perhaps between Georgetown and Columbia, for instance, but also perhaps more applied in trying to actually solicit the input from migrants themselves. Rebecca, I guess we may want to touch base at some point about that, for instance. As well as, for instance, on the interface side, where with Save the Children, there's we have an effort ongoing, but then also Michael Puma and in Hidalgo, there are also related efforts. And I think it may be very good to link up there as well. So there are a lot of bridges I think we can establish. And in that sense, I think the workshop has been extremely useful. I have no idea if/when we will organize a second workshop. If people have preferences one way or another, Diana and I think are very happy to hear that. But in any case, I think the first one was a resounding success. So thank you all for participating, taking part, and sharing your input. Just as a reminder, Diana did share a survey with these 4 questions for everyone. So if you want to share your thoughts with us, please feel free to do so. And aside from that, I want to thank you for attending, and I hope you have a good weekend.
Thank you very much.
Thank you, Derek. I think we should thank Derek as well for sharing the session. And thank you to all the invited speakers, participants, for getting back to my emails. I've been bombarding them particularly. So thank you all.
Thank you, Diana. Thank you, Derek.
Thanks, guys.
Bye, everyone.
Thanks a lot.
We'll let you know about the recording later on. So I'll be sending emails.
Thank you.
Thanks. Bye.
Bye.
Bye.